Hello everyone, welcome back to Talks Riders, an introduction to applied numerical computing course. In this video, we want to have a quick look at Python, the programming language that we are going to use throughout this course. So let's go for it. So in this video, we have two, let's say, notebooks to discuss. The first one is Introduction to Scientific Computing with Python, which is actually a very general overview on the Python ecosystem. And the second one is Introduction to Python Programming Language. And the second one it's a technical one. I want to focus more on this second one, but let's have a look at this first one, which, oops, I have to, increase the font size. And then, this first one is, saying that, for scientific computing, all the compartments of scientific computing are actually theory, computation, and experiments. And what we are trying to focus in this course is on the theory and the computation, mostly on the computation and the theory of computation. So, this is actually a discussion on that. I don't want to go for this, and there are some useful resources, but and also some tools. But what is actually what Python is, and why do we need it? Why it is important in scientific computing? Yeah, Python is a dynamic type language, and it is clean and simple, very clean. I can say human readable at the same time, but also easy to debug and follow, and easy to learn also. And it's an interpreted language, which means that you don't need to compile it. It has an interpreter that reads the code line by line and execute it. But the disadvantage of a Python is, as I said, because when it is an interpreted language, it means that it has a lower execution speed, and it becomes sometimes crucial in scientific computing, but at the same time it is a trade-off between execution time and development time. And this is actually demonstrated in this nice graph that tells you this concept, that with high level languages like Python, you have high CPU time, high execution time, but at the same time, the development time is very, very low in comparison to lower languages like C and Fortran. So this is actually why we are interested in Python. And also the Python ecosystem is very wide, and there are lots of different libraries and packages available for every single task that you can imagine in scientific computing. And then the paradigm and the ecosystem consists of various packages, various toolboxes, but the most famous ones are NumPy. We will cover that. SciPy for scientific computing, Matplotlib for plotting and graphics, and SymPy for symbolic computation. This is actually what the next 5 videos will be all about, and including this one that we will talk about Python. And in the previous videos I covered how to install Python and Python virtual environments, this sort of stuff, so I don't want to go for that anymore in this video. So let's go to the technical one, that is Introduction to the Programming Language. And the font size is good. So the .py files are the native file format for Python programs. And when you have the .py file, what you need to do is calling Python on that file, and then you have the results. So for example, in this case, you can see that there are some code behind files in hello-world.py in the scripts directory. You can easily see that they are actually here in scientific computing in course 1, and then the scripts. So here you can see that the hello world.py, and it does nothing but printing hello world on the screen. And when you run Python and Python scripts hello world.py, it prints that out for you. For characters, I don't want to discuss that. For modules is something that you saw in a previous video, that is actually some like external libraries. that you have some specific libraries that they do something specific for you. You call them. In this case, you import them into your application, and then you have access to their features. For example, for math, if you want to do, for example, perform some trigonometry operations, you can see that with the cosine and the 2 pi, and for also the constant of pi is accessible through this math package. So we import it, and then we can use it. So this is the concept of packages. You will see at the top of the Python programs a list. Sometimes there will be a huge list of packages that the programmers has actually imported. And when you want to see what a package, what a module contains, you can easily say that, yeah, directory with the command dir math, and then you can see all the functionality that it provides. Okay, so variables and types. As I said in the beginning of the video, Python is dynamically typed programming language, and it means that you don't need to specify the type of variables. You don't, for example, in C, you have to specify that this is an integer, this is a string. But here, the type is automatically allocated. The type is automatically assigned to the variables. So when you say x equals 1, it automatically identifies and recognizes that x is a floating point number. And when you say type x, it says that type x is float. And when you say x equals 1, it recognizes that this is an integer. And when you say the type x, it says that it's an integer. And when there is not, when, for example, you don't have any variable defined, for example, here we didn't have defined y. When you say print y, it says that the y is not defined. There are fundamental types, as I said, for booleans, for float, for integers, for strings, for complex numbers. You can see them here. That's quite nice. You have access to the fundamental types that we need in computing. But also you can check sometimes, because it's dynamic type, sometimes you want to assure that, for example, x is float, and then is this is keyword is the operation that you can check a type of a variable. And you can cast. Typecasting is the term in programming that when you want to convert one type to the other one. And typecasting is possible in Python, and sometimes it's automatic and sometimes it is not. And you can use, this is very similar to MATLAB or even C++, C#, that you say that x equals int x, the integer part of the x, and then that's indeed casting. And sometimes you cannot convert things to one another. Like here, you cannot cast a complex type to float. It says that cannot convert from complex to float. And also from booleans, boolean to integer, integer to boolean. These are typical things that, yeah, probably you know about. For operators and comparisons, that's very similar to other programming languages. You have integer division, you have single division, and something that to mention here, that there are some fundamental changes between Python 2 and Python 3. Python 2 was dominant for scientific computing for a decade, but nowadays it's becoming more and more popular to focus on Python 3, as the Python 2 is no longer supported. So you will see some differences between Python 2 and 3, and one of the most fundamental differences was this division operator, which is actually fixed in Python 3, but in Python 2 that was a bit weird. And then, for example, for the power operations, you have double asterisk is power operations. And then this Boolean operations, that can be true and false is false, and not false is true, this kind of stuff. And you have and or Boolean operations. And also the comparisons. That's, this is very common in programming. But let's go to compound types. They are very important in Python. We have strings in Python. That's pretty, yeah, this is something fundamental, but you may have some sense about it, what a string is. And you can see that you can define it, and then the type is str, and then you can easily say that what is the length of that. You can replace it. There are a bunch of different operations on the string. You can easily search and see them. For example, replace. You can say that replace this part with this part. And also for indexing. I will go on with indexing later. I will discuss indexing later on. But what is really important for indexing in Python is it starts with 0. The initial index is 0 in comparison to MATLAB. It's in contrast to MATLAB. In MATLAB, it starts with 1, but in Python, it starts with 0. And that's very important to remember. But if you come from C, C++ background, Java background, then it's super normal for you. And then indexing works very similar to MATLAB. It's a start and stop. So that's pretty simple. And when you say double dots, or let's say, sorry, colon, to 5, it means that from the beginning to 5. And when you say 6 colon nothing, and it means from the 6 to the end. And there is also this type that it says start and step. And I think it is a bit different from MATLAB, because in MATLAB it is start, step, end. I'm not sure, I think. But yeah, that's more or less the same. And you can see that the references is for Python 2, but make sure to check it out for Python 3. And you can see that this is string formatting. String formatting means that when you want to print out the string, you want to format it especially for the integers or floating points inside. That's called string formatting. And there are a bunch of different functions that you can format strings. And you will see practical examples during the course. So don't worry about it. I don't want to go to the details of this. Like for printing floating points, and you want to specify the number of floating points after the decimal digit. After the decimal dot, and then you can see that in action, that how we can use it. So this is actually one example of. This is actually very old method to do this, but yeah, this works, and there are better ones and newer ones nowadays, like this format keyword. Format function on a string, and you can say that it is 0. So this one is replaced with this 0, and this one is replaced with this 1. So this is actually how string formatting works. And then lists. So let's go for compound types. Lists, tuples, and dictionaries. These are very important in Python programming. And when I say compound type, it means that you can combine different types, or you can have a series or an array of something in Python. So list is you can see that it's very similar to strings, but each element can be of any type. For example, here you can see a list of integers, and when you say that the type of L, it says that it's a list. So list has this sort of fancy slicing, fancy indexing. So we can easily index. You can say that 1, 2, 3, 4, and then from 1 to 3, so it is this one, and from the to the 2, so everything with these steps of 2. So it becomes like this: 2 by 2. Ignore 1 and then print the other one. And it says that, yeah, again, for MATLAB users, start from 0. Pay attention to this, and you can have also nested lists. This can come handy some cases in Python programming, in scientific programming, but yeah. And this range command is also very important. It generates a list with this format: start, stop, end. And I say it's important because in loops we are going to use this. So you can say that list of range, stop, start, and then, for example, this is an example. You can see that how we can create a list out of it. And then you can also convert strings to lists like this, and yeah, it just divides it into different letters. You can append things to your list. So this is a very common thing you can see in Python programs. You create an empty list, and then you append the element to that. So you can append it or insert things on a specific index. So you want to insert something in the middle of a list. This is actually how you can do that. And yeah, let's go to tuples. Tuples are also very important, very similar to lists, but the difference is they are immutable. This is an important let's say term in programming. When you say something is immutable, it means that you can create it, but afterwards you can never change it. You can never modify it. That's the definition of immutable types. And at the same time, you have mutable types like lists. You can create them and then later on you can modify them. But with tuples, once they are initialized, you cannot modify them or change them. So they're very simple, but you can see that they are defined with the different symbols. The concept is very similar to list, but they are immutable. And then what is the application? They're suitable for things like returning the functions, returning the return type of a function can be like a tuple. It means that you don't need to modify it because that's a return type of a function. And also for type exchange, that's very useful. For dictionaries, so for dictionaries, dictionaries is also very similar to lists. This is also pretty useful in Python programs, but every element has a key. So it's a pair of key and value. You can see that it's specified here. That these are actually the keys and these are the values. So later on, when you want to access the elements, you can say that the params parameter 1. That's why it comes with the term dictionary. That's why they call it, because you can say that, okay, for this key, what is the value? So you can add anything you want to the list, to this type dictionary, but with a key. Actually, that's how it works. And you can see that, yeah, you can easily afterwards you can also modify it. You can say params parameter 1 equals a, and then later on you can read it. Or you can add new entries without any problem, just creating new key and then adding value to that. This is how the compound types work. For control flow, that's pretty easy. There is one thing you need to remember. That's for control flow and also for these kind of scopes or program blocks, let's say. You can see that in C++ or these kind of programs, you have these curly brackets. So when you say this printf belongs to these conditional things, if this is true, then this is the block, and then you go on. But in Python, the blocks are defined with indentation, with 4 spaces or 1 tab, 4 spaces and not 5 and 3. Anything else than 4 is an error, or it should be 4, 8, 12. Even for nested indentation, for nested things like here, statement 1, and then this belongs to this block, and then the next block to this one. So this is actually how indentation works in Python. And this one is definitely an error. You can see that it says unexpected indentation or expected an indentation, because after if you need an indentation. And then this column is also important to specify that, yeah, a block comes to notify Python interpreter that a block comes after this statement. And yeah, that's it. And whenever you have indentation, they belong to the same block, no matter if there is any space or line breaks or something. And for the loops, you can see that, yeah, this is very important for lists, tuples, and ranges. Range here. That when you say that for x in range is 4, it means that from 0 to 3. So this is actually how for loops and while loops work in Python. You can see the indentation again, and then the colon. And you can also, when you can iterate through the lists, it doesn't matter what the type is. So here, for example, it is actually a string list. And also for dictionaries, you can go through that via these tuples of key and value. So you can easily print something like this. That's pretty cool and useful. And the while loops is also very similar to for loops. What is really important is the indentation, and the rest is very similar, so you definitely know the difference between while and for. But the last things that we want to discuss, the last important things, is functions. Functions are building blocks of every program. So programmers usually break down the structure of a program into different functions. And this is actually how functions are defined in Python. So you say the def, the function name, the input arguments, colon, and then a block. So again, blocks, indentation. So when you call them, and you can call them by just writing down their names with two brackets. In this case, parentheses, sorry. So yeah, they can have also input, and the input is also dynamically allocated, dynamic typing again here. So we don't know what the type is. That's where the is keyword comes into play. So you can also pass things to that and also return things. So you can say that it's a square function is intended to compute the square of something, and when you pass 4, for example, this is square function, it returns it's squared with this double tricks, which is powers. And this is actually the way that you can return multiple things using tuples, and then you can easily read them with this. So this is very, very useful for returning multiple values out of a single function. And then the default arguments is something that, yeah, this is also has specific, some special applications that you define a function, you define a default value for some parameters, and then when you call the functions, you don't need to specify the values of the rest if you are okay with the default values. So yeah, if for example you want to change the debug flag to, debug argument to true, you can change just the debug for my func, and this p will stay 2. That's why you will see that p is still 2, but for the debug you see that it's written here that that's actually a debug flag, but when it is called with this, the debug is false. And then for lambda functions, yeah, we don't have things for lambda things for lambda expressions in this course, but yeah, there are sort of anonymous functions. Let's say unnamed functions that you define a function, but it doesn't have any name. So you are going to do some temporary operations on something. That comes very handy for lists, for list modifications or creations, and you will see probably lambdas mostly for these kind of operations that you say for x in range of -3 to 4, -3 to 3, let's say, x squared. So this is actually the output. So it is sort of creating an operations for creating lists. And then for classes, I don't want to discuss this because, yeah, we don't have things for object-oriented programming. Maybe later on we will have a dedicated course for object-oriented programming in Python, but at this moment I don't want to discuss it. It's a sort of data structure for Python programs. We don't need it at this moment. And also modules, the way that you can create your own modules. We discussed module in the beginning of the video, but this is actually how you can create your own modules, like NumPy or a math module. You can put some functions into a Py file, and then the file should have a certain structure, and then you can easily, you can import your own module into your code. Okay, that's all the things that I wanted to discuss in this video. Yeah, I hope you enjoyed this. Make sure to check out this material, but I went through it very fast. If you have followed me, then you have a working knowledge of Python, and then we are ready to dive into the modules first, and then our numerical computing techniques later on. So have fun with this, and see you in next videos.